magic pen. Oh, can you do me a favor? There's my magic pen that just went flying across the room. Right there. I call it a magic pen because it must be magical, because Harvey Norman wants like 300 ringgits for one of these pens. So there must be something magical about it for 300 ringgits. That's there, but that's there. Okay. All right, it's already recording. Okay. That's it. As I recall, I went through this program right here, and right there, I went through this already. This is one I said that when I'm done today, you'll go ahead and enter this. You should have this slide already from I posted it, so I don't need to leave the slide up if I decide to leave early, let you finish it on your own that there, but I'll stick around just for a little bit to see. It shouldn't take that long. Unfortunately, the slide is that, as I recall, it's a picture and you can't do a copy and paste from it. It would be nice if you could just do a quick copy and paste and copy that into the text editor. Unfortunately, the publisher wasn't that kind to us. That there, they did it as a screenshot and it's a image. So that there. What I typically do is I put it on one side of the screen and then copy and paste, type it from the other side. That there, but you can do it however you want. This code does work exactly as it is. So if you've got errors, it's most likely you forgot one of the semicolons at the end of the line, or you forgot a parentheses, or you misspelled the word integer. That there. So if you've got errors when you're entering the program, most likely it's a typographical error on your part, because I've ran this program at least 4 times, probably more than that, because I've taught some version of this class using this book probably for about 10 years. That there, not the exact same book, but different versions of, earlier versions of the book. But I've taught it at 3 different universities, and I've used the same book every time. So obviously I've used similar slides. That there. The only thing different about the version here than the one I've been using for a number of years is most versions that I've run, I put this int sum at the top right underneath integers. It doesn't make any difference, and it's one of the slides here, and I'm just kind of coming back to it. The rule of thumb is you have to declare a variable before you use it. So this int sum right here, this line right here, this line here, oh, well now it's on VGA and it's not working again. I don't know what's going on. I think when I threw my magical pen across the floor, I broke it right there, because it's not working now. It worked yesterday, right? Out there, and I'm using the same VGA output. All right, that's a little strange right there. I thought it was, regardless, this int sum right here, this line right there, if I moved it after the sum equals integer 1 plus integer 2, that there, I'm trying to use that memory location before I've declared it. So it can be declared anywhere after the opening brace, and this is the opening brace right here, and this line here. So I could stick that in sum anywhere there. as long as it's before it's used. Right there. Now, like here, integer 1, integer 2, I could stick those lines after these print statements if I wanted, right before they're used. I'm a huge fan of putting them all at the beginning. And if I realize I need a new variable halfway through my code, I go ahead and stick it in, but then I cut it and paste it to the top of the code at the beginning of the code. That's there. The reason people do it this way is because they're lazy, and I shouldn't call, I think it's Paul Dechtel's the son. I can't remember which one's the son, but you realize halfway through your code that I need a new temporary variable or I need a new variable, so I go ahead and declare it right there on the spot. That there. And then they don't bother going back and putting it at the beginning. That's there. Well-designed code, you sit down and you kind of map everything in pseudocode first, and you have a pretty good idea what your code's going to look like before you type it in. That's the old way of doing things. And trust me, that's the way we did it when we did with punch cards. And when we had to use punch cards and key punch machines, and you had to wait half an hour to get a key punch machine, you don't want to do trial and error. Because if you make a mistake, first off, you wait half an hour to get the key punch machine. You enter your code in one line per card. And has anybody ever seen those little computer cards? They're about, 6 inches wide or so, and about 2.5 inches tall. And they got little holes in them. Have you ever seen them in movies? But they're little punch cards, and they got holes in them. As you type, it pokes a hole in the card, and then puts the text across the top. And then those are put into a card reader to read your code into the computer, and then your code is executed in the mainframe computer, and then a printout is print out the great big printer, and then you pick it up later for the pigeonhole. And it's not important that you know the process, but that process meant that you would go to the computer room and you'd wait anywhere from 10 minutes to half an hour for a key punch machine to open up. Right there. You had to wait for an empty key punch machine. And it'd be just like in this room, if there's a final project due in 4 different computer classes, and this was the only open computer room, you have to wait for an empty computer, right? Now, from what I can see in this building, there's enough computer rooms that people can afford to go in the computer rooms and play video games. That there. Where back in the old days, we would have kicked those people out because people needed those computers to do schoolwork. Now there's enough computer room that there. But so you wait 20, 30 minutes for the machine. You spend half an hour to an hour typing all your code into the computer, into the key punch machine. You get this big stack of cards. So if your computer program is 100 lines long, you would have 100 cards. And those 100 cards would then be placed into a card reader, and you queue up and put your cards in the card reader, and it would be like the money counter at the money changer. The cards just fly through there. That's there. Then you go get lunch or a cup of coffee or whatever. Back then, we could, people still smoked on campus, so they would go outside and have a cigarette. In my case, I'd go outside and smoke my pipe. That's there for half an hour or so. Come back. Your program was ready, and you'd see where all your errors are. You go through your stack of cards, and you'd correct your errors. But in order to correct your errors, you still stood in line for 30 minutes for a key punch machine. You stood in line to put your cards in. You went out and had that there. So each cycle of correcting mistakes was an hour to an hour and 15 minutes or an hour and a half. So obviously, every time you made a mistake, it cost you an hour and a half of your time. You didn't want to make that many mistakes. So programmers back then would spend a lot more time outlining their code and writing it out on paper and testing to see how it would work on paper before they would go and start putting it in the computer, because ideally you would write your code and it would work one time and you're done. And trust me, that doesn't happen very often, but I got a little bit better at it, when I was a college freshman. That's it. Nowadays, of course, you just open up Div-C and you start typing. And then every time you've got to type a syntax error, it shows a little red line, that there, and you can fix your syntax error. You hit the compile button, it tells you that you had an error, it tells you what line number the error is, you fix it, and you hit the compile button and it runs. So the amount of iterations you do is probably more today. I mean, people probably make more mistakes, but the time to fix the mistakes and move on is much, much shorter out there. So as a result, computer programmers, and again, I'm not picking on you guys because you're young programmers and you're started, but this generation of computer programmers tend to be a little less deliberate, from the beginning. And that's okay, because the things that, if I program the way that most modern young programmers program back in 1982, 83, again, we're talking about 35 years ago, right? I would be in that computer room 20 hours a day, because of every mistake cost me an hour or hour and a half of my life. So I wanted to minimize the number of typing errors and the number of programming errors from the very beginning. Now you make a mistake, it costs you about 30 seconds of your life. You don't really care, right? You spend more time picking out what shirt to wear in the morning. So, I mean, and the ladies probably spend 5 times as much time picking out what color, head cover to wear with what color blouse, right? At least my wife does. I mean, does this color match? Is this color? I don't care. It's clothes but regardless. But we'll come back to this right there. Okay, I'm going to skip all these slides. I went through them yesterday. I talked about that in great detail. You'll do this later. I'm going to and you've got all these various slides there. A couple of things that I didn't really get much into there. I could, for example, skip the variable sum altogether, and I didn't talk about this yesterday. I'm going to unplug this and plug it back in. Still doesn't work. Let's try this again. I'm just completely confused because it worked yesterday. That will drive me crazy for the entire weekend. Nope, it still doesn't work. The magic pen is now broken right there. So okay. I could not use the term sum, the variable sum, and I can do the adding and subtracting in the same line as a print. So in other words, printf, and I'm passing it 2 variables. This time I'm passing the sum is equal to %d, of course, is a placeholder for the answer. /n is new line. Close that. And instead of putting the word sum there, I can just say integer 1 plus integer 2. I can ask it to do the addition in the print statement right there. And that's perfectly okay. It's one of those cases where you, That's there. If you don't need to use the sum anywhere else in the code, it's at there. So some programmers will do that. It's okay. It saves a little bit of typing. That there. It's probably a little cleaner to use the sum there, but there. Okay, let's go through. All right. This gets into, I haven't covered these slides, but I've already talked about this subject to a degree. We have variable names. Variable names are just simply our addresses. They're the names of things, right? Of different things that we're going to use in our program. And I say things because they may not necessarily be numbers. They can be strings. They can become very complex objects right there. But they're locations in memory. They're addresses at there. So whenever I refer to integer 1, I'm talking about a particular location in memory where I store data of some type right there. So every variable has a name, a type, and a value right there. So the name is whatever we want to call it, and we can call it whatever we want as long as we follow the basic rules, and I've already given you a couple of those rules. One is we don't begin with an underscore because underscores are reserved for library variables. We can't start with a number there, and we cannot use what's called a keyword. Now, you have to be careful with variable names that we don't use them twice. And there are cases where we can use them twice. But we're getting into a more advanced topic to where a variable may only have that name within a function, but in the main program, the same variable name means something else. And that gets to be somewhat confusing when we look at variables that's there. So a type. We have lots of types in C. So far, we've only used one, and that is int, int, which is integer. We have float, which is a floating point number, which has decimal points. We have char, which is a letter, but it can also be used as a number. Well, char is a number between 0 and 255. That's there. But it represents a letter in the ASCII code. Right there. He calls it something other than ASCII, but it's still the old ASCII code. That's there. So it can be a string, which is an array of letters. It can be a complex data type, like a student. A student has a name, a student has a cell phone number, they have a major, they may have a list of classes they're taking, they may have a GPA. It can be a very complex type that we define, but it has a type. And it also has a value that's stored right there. So here, now when we use the scanf right there, we are passing to the function scanf the address of integer 1 in this particular case. And I mentioned that before because scanf has to change the value of integer 1. It doesn't need its value. So if we pass it without the ampersand, we're passing it the value of integer 1. Well, the value of integer 1 doesn't do me any good. Just like if I sold you a car and I want you to deposit the value of the price of the car into my bank account, telling you the balance in my current account doesn't help that there. I want you to change the value of my my current account. And of course, the way I want you to change the value of my current account is by putting money into it, correct? So you need my account number. You don't need the value of my account. You need the address of my account. That there. So that's why I'm passing the ampersand. I call Domino's Pizza. They don't want to know what type of house I want to know. They want to know its address because they want to bring something to my house. So the ampersand means the address of integer 1 right there. So every variable has a named value or type of value. In addition, if they're executed, the value entered is placed in the memory location right there. So we have a location, integer 1, and we type the number 45, and it places that in its memory location right there. So again, now this they refer to this process as destructive because if integer 2 contained a number before I called to scanf, that number is wiped out and replaced by what I put in there. So that's just something to be aware of. Here I'm saying scan an integer and place it in integer 2. If integer 2 contained valuable information, that value is gone. Just like if I sold you a car and you deposited money into my checking account or my current account, it's called checking in the US, so that's why current and checking are the same thing. But you deposit some money into my current account, yeah, unless I had an idea how much money was in my account before, yeah, I don't know what was in there before you deposited that there. Well, of course, if you put in 10,000 ringgits to buy a car, and I check my current account and it says 40,000 ringgits, and I didn't know how much money was in there, I'd have to check the statement and see whether the money was in there. But the old value is wiped out. So that there. So for example, if I have a current account and I have a number of transactions, ATM withdrawals, deposits, various other things, I don't know what the balance in my account was 3 days ago because every one of these transactions changed the value of my current account right there. So, and that's what happens out there. So we call this destructive right there. Now, later we'll be passing values to functions, and those will not change them right there. Even if we change the value within the function, it doesn't change its value right there. Another note that this is kind of interesting. These locations are not necessarily adjacent in memory. That's not information you need to know at this point. Arrays are almost always adjacent, but that's it. So this just simply shows two addresses, locations and two values right there. Sum just places that there. We've declared another variable that's there. Now sum, where we say sum is equal to integer 1 plus integer 2, destroys the old value of sum. It wipes it out and puts a new value in. So an assignment statement does change the value. And we don't have to do anything magical in our code as far as addressing the location of sum. That's done automatically within a function. If we say sum is equal to 125, then it's going to stick 125 in there. Oh, and here we go. Evidently, my computer's done doing it. It's updating now. It wants to install a program on me that I started to install 2 hours ago. Right there. So it calculates it and just sticks it in there. So in this particular case, we're showing 3 memory locations, 45, 72, and then its sum. That sum is calculated with that line, sum equals integer 1 plus integer 2. Now, if you did the thing that I talked about just a few minutes ago where we did, print f and we said integer 1 plus integer 2, we don't create a location called sum. It just does the calculation within the printf command right there. So there we have non-destructive. That's where we use memory locations and they're not destroyed or they're non-destructive. Printf, for example, when we pass it sum, doesn't change the value of sum. Sum remains unchanged right there. Okay, this is the topic here for today. We're going to talk about arithmetic. Arithmetic is fairly straightforward. I'm going to fly through this relatively quickly, but you'll get plenty of practice next week on this right here, right there. So the first two functions they talk about is multiplication and remainder. Use the percent sign to get the remainder of a division. So 7 remainder 3 will give me an answer of 7 divided by 3 is 2 with a remainder of 1. So 7% 3, the answer will be 1. It's the remainder right there. Another term that you'll hear some people refer to as, it's a fancier term, and it's called the modulus right there. If you read some books, they might talk about the percent sign as being the modulus operator. But it's the term that most of you are probably most familiar when you were back in elementary school and you learned how to multiply and divide. You divide two numbers and you would often get a remainder, correct? And that remainder operator is the percent sign. It's not one we use a lot in programming unless we get into queuing programs and circular queues. That's beyond the scope of this course. So we won't be doing that. So you have to have the asterisk sign between the two. You can't just simply say AB like you would in an algebraic formula. That's there, because that would treat AB as a new variable. Right there. And remember that spaces are ignored, so even if I have A space B, the compiler eliminates the space. So it's going to just see AB and treat it as a variable right there. So the plus right there. These are the 5 primary operations. Everyone's very familiar with the first 4. Notice that on the remainder, they use the term mod for the modulus. Modulus and remainder are 2 words that mean the same. Modulus is the fancy math term. Remainder is the one that you learned back in standard 4 or something like that, standard 3, I don't know, grade multiplication that there. But we write our expression just like we would right there. So the only one that's a little different is the BM, and that's not Bahasa Melayu or bowel movement is, if you say BM in the U.S., especially if somebody who's a nursing student, they think that it means bowel movement, which is a completely different meaning than Bahasa Malay out there. But BM is multiplying the variable B times M if you write it down in an algebraic equation. But if you stuck it in a MATLAB or a computer program, you have to put the asterisk in between that there. Another one that you might see in some languages might be the star star, and that's the exponential. We'll talk about exponentials later. And I'm thinking C, and I work with too many languages over the years, I'm thinking C uses the caret for the exponential right there. But exponentials are considered a more complex operator here, so they're not covered in this chapter. But exponentials, that they're square roots and squares and those kinds of things are typically function calls, so they'll be covered later. So again, this just kind of goes through here. Integer division right there. If we're doing integer, the result's going to be an integer, and we ignore the remainder. So 7 divided by 4. If it's an integer, it's going to give you a value of 1. If it happens to be a floating point, it's going to give you the value of 1.75 right there. So it depends on the variable types when you do the math, what the answer is. Integer gives us the nearest whole number. Floating point will give us the number, a more precise number. Right there. C provides a remainder. Right there, I talked about that. The remainder can only be done with integers. The remainder function has no meaning, is non-defined for floating point numbers. Right there. So, right there, so 7% 3 yields, percent 4 yields 3, 17% 5 yields 2. That's the remainder of the operation. So that's not one you'll probably use in this class right there. It's used a lot in what we call circular queues and data processing right there. So we use that there. But it's not used in normal arithmetic. Now, when was the last time you used the remainder function in doing normal math at the store? You almost never do. Even in Aswana's class, taking math, you probably never used the remainder function, did you? So, but it does have a purpose in some types of computer programming. Some of the signal processing algorithms, we use it up there. Divide by 0 is used to generate the blue screen of death. That's an error. Now it just simply says your program crashed. A message comes up and says divide by 0 at such a location. You're a moron or bad programmers. It doesn't say that, but it just simply doesn't work. Right there. So you can't do A divided by B as like that there. You have to do it, A divided by B in this form right there. There are no multiple line instructions. If you're in a program like, I think it's MathCAD, and I doubt if any of you have ever used MathCAD, MathCAD allows this type of format up there. MathCAD was a program that was developed mostly, and I've used it, it's a nice little program, for doing mathematical publishing. I've written papers using it. I've written slides where I've used it there. So, but neither MATLAB nor C allows this format right here, A divided by B. You can put parentheses in, and you will use parentheses in order to group things. A times B plus C is not the same as A times B plus C. And right there. And we're getting a little bit into this discussion right here. Is A plus B, all right, B plus C, that's there. Let's just say, I'm just going to put numbers in here to show the difference. Actually, I did that wrong. We'll call that mistake number 1 here. A plus B times C. And let's just say that we're going to see 3 plus 2 times 4. Now, when you do normal math and you think you're going to do 3 plus 2, and that's 5 times 4, that's going to give you 20, right? That's there. Well, the computer doesn't think that way. It does multiplication first, so it's going to first do this as 8, and then add the 3, and we're going to get 11 right there. But if I did A plus B times C, and I put parentheses around the A plus B, then it will do that first. That's there. So we use parentheses in order to force a particular order of operation right there. So, and that's, again, this is not quite the same example that there. But if we, what they're showing here is that the B plus C has got the parentheses around it. So that's done before the multiplication right there. So we have, and we can have as many parentheses as we want. If we have extra parentheses, it doesn't matter. Now, since plus is an equal presence, all we have in this particular case, we don't really need any, looking at this particular line right here, we don't need any parentheses there. They're just completely not needed. So it doesn't matter if we add A plus B first, and then we add C. And then, of course, we've got an extra pair of parentheses. We've got extra parentheses there, right there. They're redundant, is the term. We have redundant parentheses. And the best answer for that is, who cares as long as the code is readable? Even if the parentheses don't change the order of operation, but makes your code more readable, put them in there, right there. So this is the order. Multiplication, division, and remainder are done after anything done in parentheses. So whatever's in the parentheses is done first, then multiplication, then addition and subtraction. Now it turns out it doesn't matter which order you do addition and subtraction, nor does it matter which order we do multiplication, division, and modulus, mod operations. Those are on the same level, but they're usually done left to right. That's there. So there, and then the assignment operator is done last, right there. So that there. So again, this just simply says the same thing. This is the formal list of order of operation right there. So this is an example. I'm not going to go through it, but it just simply shows that here I've got an equation without parentheses, and it's showing the order in which things are done. I would actually kind of go through it with my non-working pen, but it's going to multiply first it's going to multiply the 2 times 5, then it's going to multiply 5 times 5, then it's going to come over here and multiply the 3 times 5, right there. It skips the addition because the multiplications are all done first, right there. And then it finally adds those two numbers together, then it finally, the last thing it's going to do is add the 7. So just keep that in mind. If I want any other order of operation, I stick parentheses in, right there. So, right, that's it. So, as in algebra, it's acceptable to place unnecessary parentheses. I've already mentioned that. Okay, I'm going to stop at this point. It's a good place. I wanted to finish the chapter, but I have a rule of thumb, and that is don't introduce two completely unrelated topics in the same day. That there, it just leaves some confusion. That there, and I'm completely changing directions when I'm going to get into if statements and making decisions and that there. It's a completely different topic that there, so I don't want to introduce that, especially with everyone taking off tomorrow, probably for a long weekend, right? So what I'm going to do is I'm going to stop here. I'm just going to go ahead and just sit up here and encode the video and upload it. I don't know if I'll upload it. Oh, I got an Ethernet drop. I can upload it. That's there. I just have to unplug this computer. That's there. And there, you go ahead and do that one program that I had there. Once you have that working, and you're satisfied and it makes sense to you, you don't have to wait for me. Just pack your bags and walk out the door. No one's keeping track of who's leaving. I won't get insulted if you leave before I do. If I get the video uploaded before you're done working the program, I may get up and leave on you. So, but go ahead and just work on that one program and just get a little bit of practice using the compiler back there. So, all right, I'm gonna shut this off. Oh. All right. That. Ethernet adapter. Nope, I don't see it. There it is. Okay. It fell out in the bag.